Thank you for today that you have given us the gift of life and you have enabled us to wake up. Lord Jesus Christ, we come before thee, asking that you forgive us of all our iniquities, Lord. So if we have sinned before thee, we ask that you forgive us. But as we are going, Lord Jesus Christ, for this lesson, may you give us the understanding. And Father, the teacher who is going to teach us, Father, may you give him, Lord Jesus Christ, the wisdom that he might guide us, Father, to the right path. Father, even us who are going to be listening, Lord, may you enable us, Father, have the understanding and get the concept that is going to be taught in Jesus Christ's name. We have prayed. Amen.
Amen. Thank you so much for the word of prayer. You are most welcome, everyone, and thank you so much for keeping time. We shall always start at exactly 5. So 5 is the starting time, and we shall not go beyond 7 unless otherwise. Now, our topic today that we are going to look at vectors. I do understand that you may have looked at vectors maybe in mechanics or somewhere, but this is our topic that we are going to look at, and mainly it's going to be from the pure side angle. So that is the topic that you can write. Now, what is the main competency? The competency is what you're supposed to know by the end of the lesson, by the end of this particular topic. Now, by the end of this topic, there are things that you need to know, but most importantly is the application, because the questions being scenario, you need to know the applications, and therefore shall look at the different models we can have in the mathematical and within the physical world, but mainly focusing on the 2D and then the 3D space. So today in this lesson, we are going to focus on a particular aspect, but we shall look at the application of this particular topic as we move forward. So that is the competency. And then what is basically about vectors? Now, all these photos you are seeing, it shows you the different applications where scenarios can come from, where scenarios can originate. Now, in a layman's language, when we talk about vector, the word just vector originates from Latin, and vector basically means to carry. So anything that can carry something, we can refer to it as a vector. A case in point, when you are doing your biology, you looked at a concept whereby you looked at a mosquito, I think, and you said that mosquitoes are vectors. But the reason why they were being called vectors, it is because they can transmit diseases from one place or from one area to another. So when we talk about vectors, it means that we are looking at that particular thing that can carry from one point to another, something that can move you from one point to another. So that is basically where we are going to concentrate on. And therefore, if something can carry you from one point to another, it means that there are some aspects that are very important, such as the direction where that is going to take you, the length, the distance you're going to cover, all those things. So that means that scenarios, you may find a scenario in vectors that is involving the aeroplane. You may find a scenario having things concerning the water, the boat, and the rest of that. But also, you can find vectors in things concerning construction. You can find things here in engineering field. Now, all these ones shows you the application where those different scenarios can come from. A question can come from here, from engineering, from math, from physical. So you need to be very conversant with where the scenarios can come from and the different applications. But these are some of the things where our scenarios can originate from. When it comes to construction or to engineering, still you will find that we apply vectors a lot. For an architect to come up with such a design, he or she is utilizing the knowledge of vectors. So vectors is going to be very paramount for the different applications you have been seeing and those ones that you have been able to interact with. Now, when it comes to vectors, the two important things you need to learn are what we call the directions. It's going to be very important. Now, we have what we call the dimensions, and we have two dimensions. We have what we call a two-dimension. This is the most common one that we have been dealing with at O level and mainly O level and primary. Then at this level, we shall also have what we call the three-dimension. An example of a three-dimension is when you look at this house is in three-dimension. Why? Because when you look at this house, you have here where you have the 100 feet, you have this side where you have the 50 feet, but also you notice that you are going up. So that's what we call a three-dimension. When you look at your phone is also a three-dimension figure because you'll find that there is this part, there is this part, and also there is a part that goes up. So those are what we call three-dimensional figures. Now, the major vectors we shall be looking at here, we shall look at mainly three-dimension vectors. Much also we shall look at the two-dimension, but you'll find that we are mainly focusing on the three-dimensional vectors. And when it comes to the three-dimensional vectors, there are things you need to know is that in a three-dimension vectors, we have what we call unit vectors. Unit vectors are represented by I, J, and then the K. Now, your I is always related to X direction. So whenever you find I, it means that is the unit direction vector in the X. When you find J, J is always related to Y. Now, in the three-dimensional figure, I want you to please take note that your X is still remains with your I, your Y remains your J, and then your Z is always your K. How you draw the three-dimension figure, it doesn't matter. What is very important is that you have labeled it in the order of X, Y, and Z. So you can have your three-dimensional dimension thing like having here X, having here Y, and having here what? Z. It doesn't matter. As long as the order is visible that you have X, Y, and Z in that order. But not you having maybe here Y, and then here you bring Z, and then you bring X. Then there the order doesn't matter. Even if you draw it like this, whereby you have something like this, and then you have maybe here X, you have Y, and then you have the Z. As long as now you can be able to visibly see that this is X, this is Y, and then this is Z. So that is what matters most. So those are the different things. So what I want you to know is the direction, what you call the I, and what you call the J, and then also what you call the I, what you call the J, and what you call the our K. So those are the different directions we shall always have. And whenever they tell you that write it in a vector form, we expect you to have the X component with the I, then plus the Y component with the J. In case you have the Z, then you add on the Z with the K. And these are always unity direction vectors. Kindly let me know through the chat whether we're on the same page, such that we can be able to proceed. Are we on the same page? Okay, okay. Yeah, so I'm going to now ask you to summarize what are those particular things we shall be looking at in this topic. Now, in this topic of vectors, these are the only three things we are going to focus on. We are going to focus on vectors in 3 dimensions. We are going to focus on lines in 2 and 3 dimensions, and then we shall also focus on planes. So you summarize. That means that when you are making your personal research, these are the things you focus on. Do I know this? Do I know this? Do I know that? So those are the things you're going to focus on. So summarize those three subtopics. Okay. I'm going to take, and when you are abbreviating for 3-dimension, you just write 3D like that. Then for 2-dimension, just write 2D like that. But we use a capital D to mean dimensions. Yeah. I think we are going to, okay, people are telling me they have finished. So we are going to proceed. So in our today's lesson, this is the learning outcome, and we shall mainly focus on finding the magnitude and also finding the direction. So those are the two things we are going to look at: magnitude and then the direction. So here I may not go so much into details, but maybe just remind you that when we talk about vectors, I've already told you that vectors simply means a movement, means to carry something from one position to another. But what is very important, whenever we are dealing with vectors, we shall always look at the two important things, which is magnitude and then direction. Now, when you are reading or when you are making your research, that means that you are going to find vectors in any of these fields, meaning that your scenarios can involve in things concerning navigation, things concerning engineering, physics, and then the mathematics will be the language that you use to communicate in any of these three different parts. So whenever you're describing a movement, you're describing a direction and the rest of that, it means that you're dealing with the vectors. So where are they being applied? Now, engineers always use these vectors. Whenever someone is coming up with a design for a bridge, for any building. So for you, whenever you look at those buildings, there is a lot of mathematics and physics behind them. They apply them, though we may not be able to see them at the surface. Whenever it comes to earthquake things, analyzing, whenever you hear, sometimes you may hear people telling you that the magnitude of the earthquake of this particular place and the rest of that. And so it means that there were vectors that were being studied and they were being applied. Whenever you want to locate where to place, like when you are constructing a building, you want to locate where should I put a bathroom, where should I put a window, where should I put this and this. We always apply the vectors. Sometimes you may ask yourself, if I may ask, why do you think it is rare to hear scenarios that the plane has not crashed? You may find that two planes have set up, but they have never crashed. So that planning for the planes, for the route for them to use, we use the vectors. So for you, whenever you see a plane above there in space, just know that it is moving in a given direction. Even if you see them too close to each other, they can never meet or they may not be able to crash because each of them is moving in his given direction. So for them to design that space up there such that everyone knows where to go, there is application of vectors, and there is no any way those planes can move without applying the vectors, because what will happen is that they will tell one plane that for you, you remove three I may be plus 2j, then plus 5k. Then another one, it can be 2i minus 3j minus 5k in space. So each of them moves in a different direction such that they cannot crash. The same thing happens when it comes to water transport. When they are moving on water, the ships and the rest of that. Also, they have to follow specific directions. Not that they have to move everywhere. Because even when we are designing, or when these vectors are being designed, it must be specific, because sometimes when you don't follow the directions, those are the accidents you keep hearing, that there was a water accident, someone fell into this and this and the other. So that is where we can apply this kind of vectors. That means that now in your reading, in your research, keep in mind some of those particular scenarios. So a scenario can come, they can give you a plane is moving on this direction, what, and the rest of that. And then let me just give you a scenario. They can tell that a plane A set off from Entebbe using on this vector. A plane B set up from Entebbe using this particular vector. Determine or find out whether those planes can crash. So that means that for you to be able to find out whether they will be able to crash or not, we shall apply the mathematics. We shall find out that if this particular person moves in this particular direction, what are the possibilities of them meeting? If they are to meet, what could be the distance apart? So all those things are always considered. So you must know that if these two planes are to set up, what is the minimum distance that should be between the planes such that they do not crash? So such things are always designed using these particular things of vectors. Those who are going into surveying, land surveying, you want to be a surveyor, you want to go into real estates and the rest of that, in order for you to be able to align sites, in order for you to be able to get the good direction, like there is a photo I showed you, like this photo I showed you of these surveyors, whenever you see them on the road, like those who have moved, and you see people having such instruments, they are trying to align that things are in line, that the directions are okay. So all those things, we use these particular vectors. So whenever you find that a building is not straight, you see as if it is a bit cracked like that. So such things happen because these vectors were not applied rightly. Now, in your summary, a vector has only two important components, what we call the magnitude and what we call the direction. So you can just summarize that. As long as we talk about vector, it means that those two things must come out clearly. Your magnitude is the size. But in terms of understanding, when we talk about magnitude, we are talking about how strong something is. So that's why sometimes they tell you that don't put something heavy, because when you measure its magnitude, it cannot carry it on. So magnitude is how strong. In case we are talking in terms of length, how long something is. That's what we call the magnitude. Then direction, we are looking at where does it act. Is it going north? Is it going east? Is it going where? So those are the things you need to look at. But still, as we are looking at vectors, I know some of you do not offer physics, but still in this topic of vectors, you need to be well conversant that whenever you hear the word displacement, the word velocity, force, acceleration, and other words, it means that we are talking about vectors. Because the question may come and tell you that find the speed. That means that if you are finding the speed being a scalar quantity, we are not interested in the direction. That means that if the question tells you that they are interested in the speed, do not find the direction. Just stop at the magnitude. But if the question is asking you to find velocity, you know very well that velocity and speed are related a bit. The only difference is that speed only looks at magnitude. Velocity, you have to mention the direction as well. So you need to know these different components, and when do you need to find a direction and when you don't need to find the direction. When they talk about the force, when they talk about distance, you don't need the direction. So for anything scalar, when you read through the question and the question involves things concerning a scalar quantity, What is very important is the magnitude. And remember, when you are giving this magnitude, do not forget to put the units in case the units are applicable. Kindly let me know whether we are good to continue. Okay, I think we are good to continue. Okay. Yeah. Now, still here, I'm just reminding you a bit about vectors. We may not need to write everything. So now we have the different ways we represent the vectors, but it depends on the book you are reading. So sometimes we can use small letters with a tilde. So whenever you find an A with a tilde, you find B with a tilde, you find C. This is one way to represent vectors. Then those who read textbooks, in case you are reading a textbook like Understanding Mechanics, you are reading those pure mathematics books, whenever you find a bold letter, a letter in bold, like these letters here, still they represent vectors. Then also, whenever you find that they have put a letter, let me say, and they have put an arrow, it also represents a vector. But what is very important, because we have said that in vectors, direction is very important because we are going to be doing vector geometry. So I always want you to be very careful. Where is the tail and where is the head? Tail is like the starting point. Where does my vector start from? And where does it end? Because this is what determines the direction you are to take. So whenever you are dealing with these vectors, always look out for this arrow. The arrow is very important. When I write A and I write B and I put an arrow like this is an indicator that my vector will start. This is the starting point. That my vector will start from A and it will go up to where B is. This is the end point. In case I write B and I write A and B and then I put an arrow like this, then this means that my vector, this is where my tail is and this is where my head is. It means that my vector starts at B and it ends at A. So always look at that arrow. In case you just find AB but in bold, like here, that one is automatic that your vector starts from A and goes towards B. But in case there is an arrow, look at that arrow. That arrow will guide you how your vector is moving. And this is what determines the directions you are going to take. And now in vectors, still you need to pay attention to the directions. Now we know well that when we have a compass, this is like your north, this is your south, this is your east, and this is your west. Any vector that we take in this quadrant here, all of them will be positive. In other words, when you are moving towards the east, this is what we consider as a positive direction. When you are moving towards the north, this is also what you call a positive direction. If you are moving towards the west, this is negative, and when you are moving downwards, also this is negative. So it means that you need to be very careful with the different directions, whether you are a positive or negative. Sometimes they can say to the right, to the left, downwards, or upwards. So you need to know that upwards, I will be moving positively. Downwards, I will be moving negatively. So those are some of the things we are going to pay close attention to. Let me hope we are still. I'm just giving you some summary, but before we are going to continue. Now, we have different ways we represent vectors. The very important one is what we call a position vector. Whenever you hear the word position, position means that those are vectors that always start from the origin. Whenever they mention position vector, it means that that vector originates from the origin. It starts from 0, 0. And when you are writing a position vector, O is always the starting point. You can write OA. You can write OB. You can write OC. So whenever you find such, it means that is a position vector. It starts from the origin. And when we are writing our vectors always, we write them in form of the X and in form of Y. This is when we have a two-dimension vector. In case you are writing it in a 3-dimension, that means you'll have the X, you'll have the Y, and then you'll have the Z component. A case in point, when you look at our vector here, A, you notice that our vector is starting from this point. So always you have to start with the different components that I'm going to start from O as my origin. I move up to when I reach A. So the first component you write is the X. So you move steadily that this is one step, this is the second, this is the third, this is the fourth, and this is the fifth. So you notice that you are moving towards the right. And we say that towards the right, you are moving in the positive direction. That means that here our X component will be 5. Then when you reach here, remember you have to reach the final point or your destination. I'll move 1, 2, 3, and 4. So you notice that you are moving in the upward direction. And we say that anything you move up is positive and you have moved 4 steps. That means that your position vector here will be 5 and 4. So that is how you write that. But someone else may have decided to still reach the same point by moving like this, and then you move like this. Still you get the same answer as long as you know this will be along Y, and then you know that this will be along the X. So that one can as well read you. As long as you write X first and then you write Y second. So in case you have any question, feel free to ask now concerning position vectors. Can I assume everything is okay? Are we on the same page concerning position vectors? Okay, yes. So this is for 2-dimension. Now we are going to look at a 3-dimension one as well. But now let me first give you some warm up here. In the chat, I want people to tell me, to write for me, what is the position vector ought to be. So put in the chat quickly. Don't mind. In case you fail to write vertically, just write it the way as long as we get the answer. What is the position vector of B? Quickly, just put it in the chat. Okay. Okay, people are saying it is 3, 5. Okay, good. 3, 5 is okay. What about, what is the position vector OD? OD. OD. O to D. Okay, okay, okay. So people are saying 2, negative 4. Very good. Then the last one, what about O to E? O to E. What would be the position vector? O, E. Okay, okay, good. Hope everyone is saying that OE, you remove 1, 2, 3, 4 towards the left, but we say towards the left, we write negative, and then you go down 3 steps, which is negative 3. Okay. Yeah, the answers are okay. So Peter, you can check out negative where you had negative 4, negative 4, it was 3. Now, what about in 3-dimension? Now, in 3-dimension, still it is the same thing. In 3-dimension, it is still the same thing. Now, we have said in 3-dimension, what is those, sorry. So in 3-dimension, also we move in the same way. But here, we move X, we move y, we move z. But always, we must first check out how has our axis been labeled. So when we are moving to the x, you move like this. Like I'll move, this is x horizontally, y is vertically up. So I'll move y like that. Then you notice that in case it is z, I'll move in this direction like that. So let me give you now a more clear example such that we can see how to move. Take an example. This is our vector we have that is in 3 dimensions. This is your origin, which is O, and you are interested in this vector here, which is, let me say this is OA, that we are interested in OA. Still, when I'm writing, I write my X, I write my Y, and I write my Z. And please always also feel free to write it in form of I, J, and K. It is also okay. Now, when you look at it, it means that when we are moving, move along the X. But your major aim is always to reach where A is. So to move along this, it means that I can come, I move like this. Hope you are noticing. I'll move like this. Because this is the x-axis. And now when I'm moving like this is going to be my positive. So here, I will say I have moved one step. Now, when I reach here, remember my aim is to reach where A is. I'm going to go and move along Y. Y is horizontal. So I'll move like this. So when you check here, this is one step, this is 2 steps. However, when you look at our arrow, this is the positive Y. But when you look at the direction we are taking, we are doing like this, like this. This is the negative direction. It means that your Y is going to be a -2 because you are opposing the direction, but we have not yet reached A. So when you reach A, you notice that this is the Z and Z is pointing up. So meaning that now I'm going to move up such that I can reach A. So then I'll move the steps. When you look here, this is 1. When you see here, this is 2. When you see here, this is 3. So that means I'll move 1, 2, and 3. So these are 3 steps. So that means that now our position vector will be 1, -2, and 3. In case you want to write it in the ij notation, remember, this is your I, this is the j, and this is the k. So it means that you can write O to A as 1i plus -2j, then plus 3k. But there is no problem for you ignoring the 1 and write just I. Here, there is no problem for you writing it as -2j. And there is no problem writing 3k the way it is. That is very okay. Now, this is how we write when we are in a 3 dimension. I don't know whether we're on the same page. Members, are we on the same page? Kindly let me know through the chat whether that is clear. What makes 1 positive? 1, look at the arrow where this arrow is pointing. So the arrow is pointing this side. So these arrows where they are pointing, it determines the kind of direction you are taking, whether it is positive or negative. Okay, people are saying, pardon, let me remove and let me put another point. See, which point can I put? Let me put here. Let me put this is our point B. And this is our O. Yes, so arrows can be both sides. So in case, but now here, always the vector diagram will guide you. Yes, the vector diagram will guide you. In case that this arrow was not there, then it is up to you to choose any direction. But since it is there, then this means this is what we shall consider as the positive. The only one that we shall always be sure is going to be the one going up. That one we shall always be sure that that is always positive. But when it comes here, then, so in case this is point B and I want to get my vector, I'll come and I draw something like this, a line. Then I ask myself, I want to reach this point. How am I going to move? So I'll come and I'll say, I'll move like this. That is 1 step. But since it is in the direction of X, it will be +1. Now, when you reach at Y, in the chart, can you tell me how many steps of y are we going to make? Look at y. Here, we are going to be, what will be our y? Thank you, Gilbert. Thank you, Sang. So you notice that y, we are not moving any further, so y will be 0 because you are not going to move anywhere. Then after, we go up. So up, this is 1, this is 2, and this is 3. So up, you are going to move 1, 2, and then 3. And since we are going up, it will be positive 3. So that means that your x, we moved one step. Our y, we did not move because this point B is directly above the y-axis. So your y will be 0. And then the z, we shall have moved 3 steps. So that means that your position vector can be 1, 0, and 3. And that is your position vector O to B. Members, are we together on that? Not yet. Okay. 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 Members are saying, let's try out. Okay, I think let me check. I have a number here. Okay, I have this one. I have this one. I have this one. Okay, can we first try out on our own? What is vector? Hope you have not seen my answers. Can we first try out vector O to A? Now I want you to look at the axis. Now this one I have changed the plane. So now you need to know that this one being X, this is the positive. This one being Y, this is the positive. Z, this is the positive. So always look at how the coordinate axis has been drawn for a 3-dimension. Okay, now can we look at point A? Are you seeing point A? Look at it very well. How are we going to move for point A? Yes, so Miracle have said, Miracle, always look at the coordinate axis. It should guide you well. It's not like for X and Y or Z, it depends on how the axis has been drawn. So it will always depend on how it has been drawn. Yeah. So when you look at A, people are saying 2, 4, 4, 2, 3, 4. Okay, we can check out and see. Now, when you look here, we said we must have the X component, the Y component, and the Z component. So you notice that in order for us to reach where point A is, we are going to move. We start with the X. So X will move 1 and 2. But when you look at the direction, this is positive, so that is where we shall have positive 2. Then you move along the Y. So when you look at Y, this is the point. So I'll move 1, I'll move 2, I'll move 3. So for Y, it is corresponding to this point here. So when you use your eyes, for you, some of you, you may see as if it is at 4. No, it is at this point here. So they are just 3 steps. And which direction? Positive. So that means that this is going to be 3. Then you go up. So when you are going up, you instead look at this axis here. So when you look at that axis, when you try to draw roughly, you can see this is 1, you can see this is 2, you can see this is 3, you can see this is 4. That means you're going to move 1, 2, 3, and 4. So that means up, you have gone 4 steps. So anyone who has 2, 3, and 4, it is very fine. I don't know whether members are seeing that. So always look at the axis, the way it is. Hope, Matia, you have seen the mistake. Geraldine, that's okay. Jelly, you have to look at it again. Is it clear to everyone now? Okay. Okay. I think let me draw one more point here. Hope I can be able to locate one point. I wanted the... I wanted so that I can locate. Okay, here, this is going to be my point. But to be a bit more clear, this is the point I'm aiming at up there. Are you seeing the point up there? And that point, allow me to make it a bit more clear such that you don't have challenges. I'm going to stop here like that. That's where the point is. Here it is at 5. Here it is somewhere here. And here, yeah. The point is directly above here, B. So can we try out that one? And see what you are getting. Jesse is saying -4, 1, 5. Okay. -4, 1, 5, Matia. Okay, okay. The answers coming in. Husna, Faizo, Sajabi. Okay. Yeah. The answers coming in are correct. Are correct. Good. Yeah. So people have moved along the X. 1, 2, 3, 4. Then along the Y, they moved one step. And then up, they moved the 5. Yeah. Isabella, Shiba, Imran. Yes, Martina. Yeah. The answers are okay. Thank you. That is fine. Okay. What about someone said, when shall we write? Now let me say, this is where my point is. This is my point C. Here, here, here. Members, what could be our vector there? Our position vector OC, in case our point is there. This is our vector here. What could be our position vector of O to C? I hope you have seen where point C is. So what do you think will be our, oh, people are putting the answers in the chat. Okay, 0, -3, 0. Good. -2.5. Okay, yes, that is very okay. So your position vector, you notice you have X, you have not moved, Y, you have moved 3, and you have not moved along the Z. So, so Esther, if you can ask maybe where you have not picked. Esther, unmute. And Evan Soft.
I was saying I've understood.
Oh, okay.
Yes.
Okay.
Thank you.
Okay. What about Evans?
Sir, I would like
Yes.
to, pardon me, I've joined late about which one is the y-axis and which one is the x and z-axis.
Okay. Now, like this one, like when it comes to 3-dimension, there is no any specific way they can label. But what is important that always the order will be X, Y, and Z. So sometimes it will depend. You may find when they have drawn it in this format, like this, that this is X, this is Y, and this is Z. Another time, you may find them when they have drawn them like this. This is X, this is Y, and this is Z. So always, you just look at how they are being labeled. Then when it comes to direction, always your X is the I, your Y is the J, and your Z is the K. Always. That one you must know. And then when you are writing in position vectors, always write in the order of X, Y, and Z. Yeah. So your position vector, you can write it in a column form, or you can write it in a vector form in form of AXY plus YJ plus Z. Okay. Okay, I think we are good. Oh, here I've given you a point. Now, okay, here I've already showed you, but they can as well tell you to. So I, J, and K are what we call the unit direction vectors. So we shall look at them. Like when you see X, that one is what we call the unit, like unit means one. But we shall look at it. I'm going to explain further about it. So in case they ask you to sketch, now like the one you are seeing here, in case they have asked you to sketch such a point, this is how we expect you to come up with your sketch. Your sketch can look like this, depending on how you have labeled. Now, for such a case, when you look at it, it depends on which direction you are taking. I've told you, pay attention to the arrow. Now, like this, for this side, this is like your positive. This is your positive, and this is your positive. It means that when they tell us -2, I expect you to move 2 steps. 1, 2 along the X. When they tell us Y, this is Y. So Y, it means we move 3 steps. So when I reach here, I move 1, 2, 3. And when they tell us -1, it means I'll move 1 step downwards. Let me ask you to try in your book and sketch this point, and we see where this point is going to be. So you're going to sketch for me a point 3. We shall mark ourselves 3, -3, and then 2. Try to sketch that point and see whether you can be able to locate. We shall use the same axis. So let everyone first try. When you finish, you can let me know through the chat, and then we sketch it together here. Alex has finished. Gilbert has finished. Zewa. Okay. Imran. Okay. So, we give them just some few seconds, and then we see whether others have finished. Aine, let me hope you are working. Aisha, Akram, Andrew, Angel, Angela, Alice, Lisa, Catherine, Dacia. Okay. Okay, I think people have Husna, Isabella. Okay, now we can check out and then see. Okay, okay. Geraldine. Okay, so we check out and say, so I expect you. Remember, we have said this is our X, this is the Y, and then this is the Z. So this being the X-axis and this is positive, we are going to move 3 steps. So I'll move 1, 2, and 3. Then this is Y, but negative. So that means that when you reach here, you move like this in this direction. But how many steps? 3. So this is going to be our first step. This is going to be the second, and this is going to be the third. So 1, 2, 3. When we reach here, we are going to move in the Z, but Z is positive. So that means that Z being positive, we shall move up. How many steps? 2 steps. So along the Y, this is 1 step, and this is the second. So that means I'll move 1, 2. So my point is going to be somewhere here, somewhere there. People, let me know through the chat I've removed the point. Let me know through the chat whether your point was somewhere there, where ours was. Somewhere here. Okay. Then that is perfect. So that is how we do the sketch in case they have told you to locate the point. Perfect. That is okay. Thank you. Aisha is saying no. Aisha, maybe you can let us know where the problem came. Yes, Aisha?
For me, I was not comfortable with the direction, but now this I've understood.
Is it fine now or not yet?
It's fine.
Okay. Yeah. Okay. Yes, Ruth? Ruth?
Sorry, I was saying I'm requesting for pardon on Z on how to plot, not to plot, but to locate the Z axis.
The Z-axis. Okay.
Yes.
Now, when it comes, you can keep on, eh? When it comes to the Z, we always measure the movement along the Z from where all the axes are meeting. So this is the meeting point for the Z. So this is like your 1, this is like 2, this is the 3, and this is the 4. So when you are moving along the Z, it means that you can draw a line going through 1, you can draw a line like going through 2, a line going through 3, a line going through 4. But vertically, so when we are locating, let me say a movement, let me say maybe 2, maybe 3, and maybe -2, something like that. So that means that for Z, we shall move downwards here. So you first move this X here. For X, you have understood X, you move like this, 1, 2. Then Y, you move depending on the positive. So for Y, it will be like this because that's how this it's going to be like this. So you move horizontally. But when it comes to Z, since it is negative, you move downwards. But you measure from here that I'm going to move down 1, I'll move down 2. And then you come where this line here, and the one you have moved along the Z will meet. So it will be a point somewhere here, down, down, down. I don't know that you are picking or not yet. Ruth, have you picked something? Not yet. Let me first get Ruth again.
Yes, I have. So teacher, the
Okay.
point is the first locate call for me the point again.
The point for
Yes.
this particular one. Okay, give me a
Yes.
point.
Okay, the previous one we have done it was 3
3,
what?
3 may be negative. Maybe 3, 2. No, negative something.
Yes. So it's 3 first from the positive side of X, then
So
3,
you moved like that, right?
then to the negative side of Y, 3.
So now the Y, are you seeing the Y? This is the step, this is the
Yes.
step, this is the step. So you moved like that.
Yes. Then now the 2 will move
That 2
upwards.
positive.
Yes.
And this is the Z. Are you seeing the Z positive?
Yes.
Now you first locate where are they meeting. This is the meeting point, right? So this is like your 1, this is like your 2. But remember, you are at this point here. This is where you have ended.
Yes.
So that means that you are going to, let me see. So that means that from here, you are going to be moving up like that, like that, like that.
Oh, so for me to
So
get a
you'll
point,
find
I join from the origin to that arrow, the tip of that arrow.
yes. So
Oh,
you
okay.
join
Thank you.
from here like that.
Okay. Thank you.
Okay. O- Okay. Okay. I think now we are good to go. Okay. Then we have other vectors, like what we call the displacement vector. Now, when we talk about a displacement vector, those vectors do not start from the origin. So far the vectors we have looked at, they are starting from origin. But we have some vectors whereby the measurements are not done from the starting point. Now, for such vectors that do not start from the origin, such vectors we call them displacement vectors. So for any vectors you'll find with the two letters without an O, those ones we shall classify them as displacement vectors. Now, take an example. I have a vector here. When you look at this vector is LM. Now, we have said that in our vectors, always we can write in form of xy, in case they have asked you to write in a column form, but also writing in form of xi and yj is important, is okay. What is very important, first locate where is your starting point. We say that the first letter shows you where you are starting and where you are ending. So for such a case, this is L and this is M. You ask yourself, how can I reach M from L? Some of you can say, I can move like this, then I go up. But look at the direction, you have moved like this, you have moved like that. This is very okay. Another person can say, for me, I don't want to move like that. Let me instead move in another way. So someone can come and say, maybe for me, let me move, Someone can come and say, me, I want to move like this. So you come, you want to move like this, you reach here, and then you go like this. That one is also very okay. The most important thing is that have you reached your destination? That yes. Now pay attention to the direction. That how many units are along here. That this is 1, this is 2, and this is 3. So this is going to be 3. Then up, this is 1, 2, 3, and 4. And therefore it means that your vector is going to be 3 and 4. And which mistake do we usually make? Some of you just read here that this is 1 and 2, and then you write 1 and 2. This is not okay. So in case they have given you in form of a graph, for you, you look out how many units do you have. Alternatively, we are at one point we are going to look at in case it is not graphical, how can we approach it? So we shall look at the derivation. But let me test whether at least we have picked something on direction vectors. Everyone in the chat, what could be? This box is just 1 unit, members. You tell me what is vector df. What is your vector df? df. People are saying 3, 5, 3, 5. Very good. Members, what is our vector? D, E. D to E. Hope everyone is seeing. In case you are not seeing, you let us know. And we help you. Alex is saying 10, 2, 10, 2. Okay, okay. That is okay. That's good, members. Okay, I can put those who are not seeing. let's move. So you check out how are you moving? How are you moving? So people are moving like this. After reaching here, they move like that. Okay, but I'm seeing everyone at least he is obtaining those ones. Okay, good. Let me check whether I have another one. I have another one here. Oh, okay. Imran, you can ask. Yes, Imran.
Good morning, sir.
Morning.
On the previous chat that we are from,
Mm.
the answers that were for vector DF, people are saying it's 3, 5. But
Okay. Can you? How
aren't we
did you
moving?
move?
I moved from D going to
Mm.
the north direction.
Like that?
Yes, and then went to F.
Uh-huh.
And mine was 5, 3. Is also that correct?
5, 3. Okay. Imran, how do we write vectors? What do we start with? Which component do we start with?
I and J.
I and J. On your 5 and 3, what is your I?
Oh, it's I. It's 5.
Your I is?
5.
Which direction is I? Mm.
X. Oh,
Eh,
my I is 3.
Your I is 3 and your J is
Yes. My J is 5.
5. You can now tell us
It is 3, 5.
it is 3, 5. Okay.
Thank you, sir.
Okay. 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 So here, members, I want us to locate quickly. Feel free. I'm going to ask people. You can. Someone should give us a B. Feel free to raise your hand. Another one should give us CE. Another one can give us GH. Okay. Yes, Evan Soft.
So, teacher, according to what you've answered to him,
Mm.
does it matter to give the sign since we are now following the x and y? Let me say to say since we are coming from positive, then it will be a positive for x and negative for y.
Yes, it is okay.
So it had to be positive 3, negative 5.
Oh, for the other previous number.
Yeah.
Okay, let me go back soft and you see. Now soft, when you try to draw your coordinate axis in this format, like this, are you seeing?
Yeah.
Is your y positive, negative?
Positive.
Positive. Yeah. Hope now it is okay.
Yes. But teacher, so
Mm.
according to
Yes.
the direction I'm
Mm.
moving downwards, doesn't that make it a negative?
Okay. Soft, are you looking at how we are moving?
Yes.
You are moving like this, not so?
Yes.
And this. Are we moving down?
So teacher, take also the other alternative.
The other alternative is this and this.
Can't I come from F to D?
Now that one you have changed. Now that one is FD, and it means you are opposing the arrow.
Okay.
Hmm.
Thank you, sir.
Okay. Oh. Okay. Members are telling us ABDH. Okay, AB. There was DH. I think even I'd given you GH, something like that. Okay. Someone is telling us AB. According to what I'm seeing in the chat, people are getting different answers. So remember for these vectors, first join them. Join. Show your arrow that are moving from A to B like that. So Miracle, check out your answer. Matia, we on track. Shiba, that is okay. Edmond, that's okay. Kendra, Luke, Isabella, check out. Gloria, check out. Ivan, check out. Then G to H. Make sure you join them. You first join them very well. And now they said GH. Put your R and then C. Patrick, check out DH. Then we talked about DH. Okay, DH is like that. Okay, so I'm going to give here the answers and then you mark yourselves. So for DH, I expect you to have 3 and 3. For GH, I expect you to have GH to have 4 and 7. And then for AB, I expect you to have 2 and -1. That's how I expect you to have those ones, because when you look at AB, you are going to move like this, and then you move like that. But in case you have any question, kindly ask. Yes, Esther?
I don't know how you've got the answers for A, B, D, H, and GH.
Okay. Esther, stay
I don't
on.
know. Yes.
Okay. Okay. Now, Esther, we are going to do another one, and then we use that one. So what we do, in case, let me say, Esther, can I use CE? Are you seeing CE?
Yes.
So the first thing you do is connect those 2 points, C to E. Are you seeing?
Yes.
Then you ask yourself, this is the direction C to E. How can I move from C to go towards E? Tell me your movement. How can you move? Remember, in vectors, we move horizontally and vertically only. So tell me how you can move. Or which move?
Negative
So we can
3
start horizontal, right?
horizontal.
So 1, 2, 3. So how many steps do you have along the horizontal?
3
But which direction are we taking? Negative, positive?
negative.
Negative. Then when you reach here, we move vertically. How many
Yes.
steps do we move up?
1 positively.
1 positive. Okay. So how shall we write our vector now?
Negative 3 1.
1. Is it okay now?
Yes.
Okay.
Thank you.
All right. So that's how we have moved to others. Okay. The rest, feel free. I'll share this document and you can try out to figure out any other. So I have here for 3 dimension. For 3 dimension, I want us to first try, and this is the work. I want people to tell me what is our vector AG. So try, move very well for 3 dimension. So move and then we see whether we are picked how to read a 3 dimension figure. Mhm. Mhm. I've seen Alex, I've seen Matovo, Jesse. Okay, perfect. Oh, Gilbert, check out. Eh, so we can try. Oh, Chiza. So we can try it together. So we are moving from A towards G. So we said we have to get our X, we have to get the Y and the Z component. So I'll come. Look at where you are starting from. This is the starting point here. And this is the end point. So I'll move 1, 2, 3. Look at the direction that this is positive. So here we shall have 3. Then we have stopped somewhere here because you have moved 1, 2, 3. Then move along the Y. We shall move 1, 2, 3. So here our Y is going to be 3. Then for vertical, remember what you do first. For you can first draw here. You can first draw like this, such that you are not confused by these ones up here, because some of you only look here. And then you come and say, this is 1, this is 2, and this is 3. So that means you have moved 1, 2, and 3. So that means the answer, anyone with 3, 3, 3, you are very correct. Members, is that clear? Is it okay? Okay, members are saying it is very okay. Why don't I give you at least another one? Can I give you, Ivan, raise up your hand. I want to pick you. BH. Try for me now, BH. Let's use the same figure. BH. Let me clean. So we are doing BH. Ivan, you had a concern. I wanted to take on your hand. Asaba Ivan, you can unmute. Yes, Ivan.
Good morning, sir.
Yes, good morning.
Sir, I would like pardon from how we are getting that edge.
H.
Yeah.
Okay. I'm going to repeat. Let me first check out the answers people are getting, and then I'll explain at once.
It's okay.
Okay. Now, Ivan, don't go off. What you need to know is always look at these axes here. Are you seeing them?
Yes.
We have
Yes.
said that when we talk about a displacement vector, it does not start from the origin. So I do expect that for such vectors, what are you going to do? First, draw a line joining from B to H. So you come, draw your line from B to H like this. Then the next question you always ask, how can I move along X, along Y, and along Z for me to reach H? So the way to do it, first move along the X. So along the X, it means you are going to move like this. When you reach here, you are going to ask yourself, how can I reach H? Then it means you move like this. Are you seeing the movement?
Yes.
Then from here, it means you are going to move where? Up.
Up.
So when you look here, Ivan, how many steps have we moved along the X?
3.
3. Then which direction have we taken when you look at this axis here?
Negative direction.
Negative. So you say -3. Then you ask, what about along the Y? How many steps have we moved?
3.
3. Which direction?
Positive.
Positive. Then lastly, what about the Z? How many steps have we moved and in which direction?
3 in the positive direction.
Okay. So that is how you write it.
Yes.
Okay. Yes, Milako, you can unmute and then Imran.
Good morning, sir.
Yes, good morning.
So my question is like, why didn't we follow the other path from
Uh-huh.
using the path of BC, where we only following the one of B to A then H?
Yeah. Okay, you take us through. How have you moved? Like
May I
this?
moved, yeah.
Uh-huh.
Then 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 that's why I got confused.
Okay, still here, you can either move like this, are you seeing? Or move
Yes.
up to here. Alternatively, you can decide that you'll move like the way you had moved like this. When you reach here, you go like this. When you reach here, you go up. Now, which one do you want to use? Or which one should we? Or both?
The pink one.
The pink one. So how many steps have we moved here?
3.
Which direction? Positive, negative?
Positive.
Positive. Which axis are we moving on?
That is the y-axis.
Y. Then we go to the second pink. How many steps have we moved?
2, 3. These are
Which
also
direction?
2. They are moving in the positive direction.
Which axis?
That is the z-axis.
Then we go to the last one here.
1, 2, 3. And
Then
that is the y, the x.
the X. And which direction are we taking?
We are taking the negative.
Negative.
Yes.
So, Mira, can you think that the answer is the same?
Yes, teacher.
Okay.
Thank you, sir.
Okay. Yes, Imran?
No, sir, it was also the same concern.
Oh, okay. Yes. So members here, you can take any, like the way Imran and Miracle were asking. So you can take any. As long as you reach your destination, it doesn't matter where you have passed. As long as you move horizontally, vertically, yes, as long as you move in that form. Yes. Okay. Okay. Do we need to do one more point? Now, if I'm giving you another point, it should be a point somewhere. Where? Okay, I needed an axis, but okay, but maybe I'll try to get for you some other. But someone was asking about CE, still you do the same. So you move like this, and then come up. So that one I expect to have -3, then 3 for CE. Okay. Then you can write your heading as magnitude, modulus, or length. Yes. And here, the only thing I want you to summarize is this. Just summarize this is what is very important. Now, when they talk about magnitude, they refer to the size of something. They are referring to the weight. In case it can be how big something is. That's what we call the magnitude. So when we are finding the magnitude in 2 dimensions, I hope you still remember from your O-level math, even as I think at primary, this is how we find the length for 2-dimension figure. So in case you have any question, you may ask, but I wanted to concentrate on a 3-dimension figure. Feel free to let me know that we are good to continue. Okay, members are suggesting we can continue. Okay. Now, the one I want us to look at is what we call a three-dimensional figure. Like I've said, I wouldn't love you to cram, because at this level of A level, when you cram a lot of things, you may end up confusing yourself because it is a lot there are a lot of formulas you are still doing. Now, when you look here, I'm going to look at the length of A to G. Now, when I'm looking at the length of AG, I'm asking myself, what is the distance from A up to where G is? What is important? One is for you to know that if I'm moving from A to G, how do I move? That when I'm going from A to G, members, you will agree with me, I can move like this, which is A to B. Then from B, I can move to where C is, then plus B to C. Then from B to C, I can move up here to where I have C to G. Members, is that fine? Is that okay? That movement, are you seeing that movement very well? Yeah, members are telling me, yeah, they're able to see it. Now, if I'm looking, so that's how we can reach AB. But if I want to obtain this line here, the length, what does it mean? I'm going to put some line here. Let me change the color. I want you to check out this triangle. I have this triangle here, and a triangle up here, and a triangle. I'm going to extract that triangle. I want to extract this triangle like this, a triangle like this, and then a triangle like that. And when you look at that triangle, you notice very well that this is where I have my A, this is where I have my C, and this is where I have my G. When you look at our C to G, this is what we call the Z-axis. So here, I'm going to put my Z-axis. Now, my task is to look at this triangle we have down here. Hope members can see it very well. I have a triangle here. This is A, this is B, and this is C. You know that from A to B, this is the x-axis. From B to C, this is the y-axis. Meaning that if I want to get the length here, A to C, I'm going to use Pythagoras theorem. So you know that A to C squared will equal to A to B squared, then plus B to C squared. Now, my A to C squared is the same as my A to B is the x squared, then B to C is the y squared. Members, do you agree with me on that? Is that fine to everyone? S to C squared? Matov says not, yeah, but yeah, yeah. Okay. Let me now write on the diagram here such that people can be able to visualize it further. A to B is X. B to C is Y. So in order for you to get this hypotenuse here, we use Pythagoras theorem. It's like having a triangle. So if you want this side here, whereby here you have A and C, and this is X and this is Y, for you to be able to get this, you use Pythagoras theorem, that A to C squared, or what you have as A squared, is equal to B squared plus C squared, depending on how you have labeled it anyway. A. So this one, in case this is my A here, this can be my B, and this one can be my C. But the way you understand, I think you are used to C here, A, and B here. But that is Pythagoras theorem. So you notice that from A to C, I'm going to do. So in order for us here to get our A to G, I will say AG squared will equal to SC squared, then plus CG squared. Members, is that fine? Is that fine from Pythagoras theorem? Hope you can see it very well how I'm coming. That to get A to G is the same as SC squared plus CG squared. But we know very well that A to C squared, SC squared from here is the same as X squared plus Y squared. plus now C to G, which is Z. So this was going to be Z squared. And this is our A to G squared. That means that in order for us to get our vector, our modulus, it means that A to G will equal to the square root of x squared plus y squared plus z squared. And this is what we call the length in a three-dimensional figure. So whenever you have a three-dimensional figure, to get the length, to get the modulus, for you just square your x component, square your zy component, and then the z component. In a two-dimension, just square the x and square the y. Members, can I assume it is okay? Imran, I've not yet picked. I don't know where the problem is. Imran, you can unmute.
So I'm requesting a pardon. I've not gotten where this x squared, where okay, you have brought in the z squared from. Yes, there is also
Are you
a
seeing this
squared.
SG? Did you understand this SG? How SG came?
The CG,
Hmm.
yes, from
Yes,
the
CG
triangle.
is along the Z axis. It is okay?
Yes, yes,
Then, are you seeing the line A to C?
yes,
Are you seeing A to B?
yes,
So A to B is along the x-axis. So I'm calling A to B x. Then B to C is y. You agree?
yes.
Now to get this hypotenuse here, this longest side on our triangle, we use the Pythagoras theorem that c squared is the same as a squared plus b squared.
Mm.
But your A is this x and your B is the y.
Right. Oh,
Fine?
oh
So that's
yes, yes,
how
sir.
it is coming about. So when you apply Pythagoras theorem again on this particular one, instead of us, here I didn't want to get the square root, but here you notice that sc squared is the same as your c squared. So whatever you have for your c squared, you carry it the way it is. So that's why I just carried x squared and y squared the way it was. Is it okay now? Not yet. Okay. So that is how we find it. So can we summarize? Summarize in your book. Yeah, just summarize about the three dimension. Okay. Okay. Okay, people are finished. Okay. So we can start. So they want us to find the length for the first one. I'm going to just put space here. So in case you want, feel free always to first label. Someone can say that let A equals to 3i minus 4j. There is no problem with that. Even if you let such that you know what to do. So may I ask everyone to first try the first one and you give us the answer in the chat, what you are getting. Okay, people are getting 5. Very good. Very good. Hope no one is finding challenges on that. Now we go to part B. Okay, Esther, yes, Esther, you can come in. Yes, Esther?
I don't know how we are using the I and J to find the units. I don't know how to find the length.
The length. Okay,
Yes.
Can you tell us what is the formula for finding, so length, we represent it by that, but we have said that when we have 2 dimensions, I and J, always we shall have x squared plus y squared. Is that fine,
Yes.
Esther? So
Yes.
when you look here, what represents your x?
3,
3. What is representing your y?
4.
Come again.
0.
Y?
Y 4.
Negative 4.
Negative 4.
So what you do, you substitute here. Substitute for us. What shall we have?
3 squared plus negative 4 squared.
Plus negative 4 squared. Continue. What shall we have?
9
Mhm.
plus negative 16. Plus
Now
6 plus 16.
plus 16.
Yes.
Continue.
30.
Add well. Add well.
20, 25.
25. And you end up with
5.
5. Yeah. So that's how
Thank you.
they are getting the 5 units.
Thank you.
All right. Okay. Okay, we can have someone to take us through part B. Who wants to take us through part B? Okay. Let me see. Okay, Shadik.
Good morning, sir.
Yes, good morning.
So I think we're going to let this whole thing
Uh-huh.
to be, maybe we say let y equals to
Okay, I'm going to first discourage y, x, and z. So better use that later that may not confuse at a later time.
let m equal to negative I plus 2j minus 5k.
Okay, good.
So that we're going to use magnitude signs
Okay,
for
can you
m.
first extract for us your x, y, and then our z?
Okay. Our x is going to be negative 1.
Good.
Y is going to be 2. And then z is going to be negative 5.
Okay, good.
So we're going to have magnitude of m is going to equal to root of x squared plus y squared plus z squared. Then you're going to substitute and we shall have into bracket negative 1 squared. Then we shall have 2 squared. Then plus negative 5 squared. So this is going to be equal to 30, which is 8.
Which is?
I think that can be simplified to, let me see. That can be
Hope that's what you have.
yes.
Okay, thank you. Yeah. Okay. Yeah. So the answers in the chat are okay. The answers in the chat are okay. Okay. And then for part C, people are saying they're getting 14. Yes, Gilbert?
So I'm asking whether is it a must that we must simplify the square root or we can leave it as a surd?
Oh, now it will depend on the item and the question. In case the question does not specify, then the best way is to simplify it. Is to
Yes.
simplify it. So you write your root 30 and then you write your final one. Here, the beauty is that in case someone was interested in root, you'll get the answer. In case someone was interested in the point, he'll give you the thing. But if you leave it at only root 30, it puts you now on disadvantage. What if someone wanted it in a point form? So you lose out. But here, he'll mark what he wants. So, but the best is always simplify it and have it written to at least 4 decimal places, unless otherwise, or when it is stated.
Okay. Thank you.
Okay, yeah. Okay. Members, are we good to continue? Anyone we are leaving behind and you may need help, or we are good to continue? Okay, people are saying, I think we can. Yes, Esther? Oh. Kendra? Okay, I think we are going to continue. And I'm going to ask people to do for me part A. We first try out part A. Yeah. We try out part A first. Everyone, find 4A, put your answer in the chat. And then we see. I want first test how much knowledge we have on that particular thing. Okay. Alex has finished. Okay, good. I think we are going to summarize. We are going to summarize that particular thing together, and then we continue. Now, in vectors, there are 3 things we need to learn. One, there is what we call addition, subtraction, and what we call scalar multiple. So allow me to summarize all the 3 on this one screen. Now, the first one I'm going to start with is what we call addition of vectors. So, addition of vectors. Now, when we are adding vectors, always remember we add components. Let me say I have my vector A, which is 2i. Okay, let me use xi plus yj. And I have another vector B, which is maybe x1i plus y of y1. When we are adding two vectors, we always add x with, I and I, j and j. Always make sure you add them that way. Someone can as well put them that this is xy plus the other one, which was x1 and y1 in that form. So when you are adding this first component and the first component are added together, the y component and the y component are always added together. In other words, you have x plus x1, then you have y plus y1. So that's how we add those two vectors. So always make sure you add the individual components of I and I, j and j. The same thing happens in case we are working with a three dimension. Let me say you have 2i plus 3j plus maybe 5k. And you have another vector b, which is 3i plus 5j, then plus 2k. Still, it means that when you are adding, it is okay. Someone may just write this in form of 2i plus 3j plus 5k, then plus your b, which is 3i plus 5j plus 2k. And then after you start adding the i's and the i's. So you set to the 2i and the 3i, then plus 3j plus the 5j, then plus the 5k and the 2k. So the i's and the i's can be added together. So 2i plus 3i, you end up with 5i. 3j plus 5j, you end up with the 80j. Then the 5 and the 2, you end up with the 7k. That is okay. And remember, when you add in vectors, you remain with those components of I, j, and the k. Alternatively, someone may write them in a column form and write this as 2, 3, and 5 for the A component, and then you add it on the B, which is 3, 5, and then the 2. Then you start adding this corresponding component, this and this, this and this and this. And then you end up with 5, 8, and then the 7. This is very okay. And then you write it back in the I, J, and then the K notation. Why don't you try for me one here quickly? I have my vector A as 2i plus 7j plus the 2k. I have vector B as I plus 2j then plus 3k. In the chart, what is our vector A plus B? Shiba, good. Okay, Navish, that's okay. Matovu, Gilbert, Waram, okay, perfect. So the answers I'm seeing in the chat are very fine. Good, good, good. So that's how we add. That's how we do add the vectors. What about, I'm giving another one. Vector C is I plus 2k. Vector D is 2i minus 3j plus 5k. Members in the chat, what is our vector C plus D? Wow, 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 wow. Hans Shapiga. Yes. Yes, Matovo, Alex, Ivan. Okay. That is very good, members. That's very good. Now, the same idea we use for addition is the same idea we use when it comes to subtraction. Still, when you are subtracting, we subtract those individual components the way you have done. Joyce, that's okay. Dorcas, that's okay. Allison, that is okay. Yeah, Joyce, that's okay. Very good. So the same way you add is the same way you do for subtraction. Only the sign changes. Let me start with giving you a number that I have 5i plus 3j plus 7k. My vector b is 2i plus 7j, then plus k. Members, can we get a minus b? In case you feel we are leaving you, feel free to raise your hand and then we can support you. In case there is something you feel you are not getting right, feel free to raise your hand. Lenovo checkout. Gilbert, Ivan, Alex, Navish. I'm seeing the answers. Maria, Matofu, Adol, Cab. Okay, Edmond. Yes, I'm seeing the answers are correct. Ronald, Matthias, Samsa. Yes, Geraldine, Ken. Yeah, the answers are very correct. Joyce. Okay, good. Anyone we are leaving behind? Members, can I assume we're on the same page? Linda say Isabella. Okay, are we on the same page, everyone? Patrick, Ziwa, yeah, the answers are very correct. Yes, Samsung is saying yes, we're on the same page. Okay, people are saying we are on the same page. Okay, then the last one is what we call scalar multiplication. A scalar is just any number that can magnify, that can change direction of any particular vector. So a scalar is that number that multiplies a vector. Take an example. In case I have k and I have my vector ai plus bj plus ck. So a scalar, let me use here another letter. K will confuse us. Let me use another letter apart from K. Let me say I use, let me say P. Now, whenever there is any number outside a vector, this number here will always affect each individual component. This P affects the A, this same P affects the B, the same P affects the C. But you just multiply. So you multiply P times AI, then plus P times BJ, then plus P times CK. But at this point, please, in vectors, let's avoid using times. This times here, it may change the meaning. So just have PAI plus PBJ plus PCK like that. So don't show the multiplication using the times because in vectors, the meaning may change or it may be interpreted differently. Take an example. In case I have 2 times maybe vector 3i plus 2j then plus 3k. These two outside will multiply everything inside. Individual to multiply the I, the j, and then the k. So in other words, you have 2 times 3 of I plus 2 times 2 of j, then plus 2 times 3 of k. And then you end up with 6i plus 4j plus then the 6k. That is the impact of the scalar. So it multiplies everything. But why don't I first give you one? I have my vector A equaling to negative 3i plus 4j plus 5k. Members, can we quickly find what is our vector 3a? So when you find 3a, it means that multiply 3 with all the individual components of A. So can we try and see? Wow, good. Yes, yes, the answers are correct. 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 Yes, yes, yes. Yeah. Okay, perfect, members. Okay, let me first speak on Esther. Yes, Esther?
I had seen people in the chat. There are, some people are putting 9, 12, and 15, and other people are putting 9i plus 12j plus 15k. Are we supposed to put those units, or we can answer just like that?
Oh, okay. Answering is okay. But when now we are presenting, we present with the I, the J, and the K.
Oh, okay.
So here, your final answer has to be here, just because it is a quick one. Yes, but your final answer, I expect to be negative 9i plus the 3 times 4, which is 12j, then
Yes.
plus 15k.
Okay.
Yes.
Thank you.
All right. Okay, now I think this is enough grounding. So, why don't you are doing for me part 2 and do part 1, part 2 in your book, do part 3. We first do those 3 parts and then we see which answers we do have. When you finish, feel free to put your answer in the chat. Okay. Okay, I'm seeing answers coming in. Okay, good. I'm seeing here Alson, Jonathan, Alex, yes, yes, yes. Jesse, Samsung, Joyce, Mark, okay, Elvis. Feel free even up to part 4. Feel free to do up to part 4. But in case you get stuck, there's something, feel free to raise your hand. Okay, Alex. Alex, unmute. I'm seeing your hand up. Okay. Okay, Chiza, Alison, Joyce. Okay, I'm seeing the answers. Navish, Sarah, Helen. Okay. Geraldine. Geraldine. Okay, part 4. Okay. Okay. Geraldine, let me start from Geraldine. I don't know that Geraldine, you can do for us that part 4. Yeah, you can take us through, Geraldine. Yes? I'm not getting you clearly. We shall subtract. Oh, okay. I didn't get you clearly. I think it's your network. Okay. I think the network. Yes, John? Geraldine, I think your network's not so clear. Let me test. Maybe it's mine as well. Yes, Johnny? Sorry? I think it was my network. It was my network. Geraldine, come again. I want to see whether it is now clear. Yes. How did you do it?
So we shall first subtract the vector A. Yeah.
Okay. So you subtract A minus B.
I yes, one. Yes. Shall have so we shall get -2.
-3, uh-huh.
Zero. 0. Then -6.
Okay.
Shall not play the scalar.
Okay. And what did you get?
And then -6. 0. Then
Okay.
yes, it's like,
Okay.
so that makes it also.
Okay, correct. Now, members, thank you, Jardine. So I expect you that for all these answers, when you look at our answers here, they were given in I, J, K. So if you use this approach, your final answer must go back into the I, J, and the K notation. So don't leave your answers like this. Unless when your answer was given like that, that's when it is also okay to leave it like that. But in case it was given IJK, please go back and change it in that form. Okay, you have a question?
Yes, sir. I have a question.
Yes.
Like if we have the answer we have been given the answer and I've got it. Am I supposed to include like the unit vector, like I have 0 in the middle there, like -6i, 0, z, and what? Negative 12k. But what if I just ignore 0, 0j, and then I say is -6i, and then is 12k? Am I correct?
Okay, yeah. Now that is also okay. If you want, you put there. If you don't want, it is okay. So this one is okay. Even someone who puts something like this. Yeah. But here, when you put 0, this is negative. When you put 0, it does not make any difference. It does not make any difference. But it is better you ignore the 0 because it is negligible. Does not have any effect.
Thank you, sir.
Okay. Okay. Yes, Geraldine?
I think somewhere I had something to say.
Who? Samuel.
Somewhere. Yes.
Okay. Samuel, unmute. Samuel, you
Yes.
can speak.
Yes, good morning, sir.
Morning.
I also had a question on that very part 4. I wanted to confirm whether that 0 can be unmute or can be ignored.
Oh, it can be ignored, and it is okay to ignore it.
Okay, thank you, sir.
Okay. So may I ask you to take a screenshot of number 2? This is like your homework, number 2. But maybe just to say something, when they say AO and a question has given you O to A to O, it means just a change in direction. So this one is like indirectly telling you multiply -1 times OA. That is the meaning. Yes, Dorcas? Okay.
Good morning, teacher.
Yes, good morning.
Teacher, I'm requesting for clarification on the other parts. Part that one Roman numeral 1, Roman numeral 2, and Roman numeral 3, because you're all getting different answers.
Okay, what do you have for Roman 1?
Roman 1,
Dorcas.
I have 4i plus 28j minus k.
Minus?
4k.
That is very correct.
Yeah. Then for part B, I have 12i. I have 12i plus 21j plus 15k.
That is very correct.
Then for part C, or part 3, please, I have 2i.
Your final answer?
Negative 2i, sorry. Is it
Okay,
negative?
let me write it here. You have?
Okay. The final
negative
answer.
2? Yes,
Negative
the final answer.
negative 2i plus 7j minus 7k. Minus 7k.
This is also very okay.
Okay, thank you, teacher.
All right. So members, those are the answers I expect everyone to have for that particular part. Okay. So then the last one, the last exercise is here that you are going to try out. I don't know that is the last, but just take a screenshot. Hope you have finished. Yeah. Yes, but I'm going to ask you, I'm going to add something here that after finding these vectors, kindly go on and find the length. The same thing here, also go on and find the length. Go on and find the length. First find such that you try out also that part for finding the length. Okay, so we are going to end at this point here. We shall start from here tomorrow, and tomorrow we shall continue. After this part, we are going to look at displacement vectors in length. We shall look at vector geometry, and that's what we shall have tomorrow. Those diagrams you had at, I think, yeah, those diagrams, we shall look at that as well. But let me take on some hands. Imran?
Thank you, sir, for the lesson. My question is, this part of vectors is the one in mechanics or the one in pure mathematics?
This is now pure.
Oh.
But please take note, it can cut across. Still here, you are going to find that we are going to, because in the competence-based curriculum, it's not that we are going to be direct, the questions will be direct the way they were in the previous years. No, here you may find that you are almost doing like pure, but we are bringing in some physics concepts. Because we are going to look at the application of vectors, like I showed you at the start of the lesson, that by the end of this topic, the competence requires us to be able to do models that are in the physical world. So that is the physics side, in the physical world and the mathematical world. So you'll find that we are going to design models, or we are going to have scenarios or applications involving these things. Hope that is okay, Imran.
Yes, sir. Thank you, sir.
Okay. Yes, Arnold?
Good morning, sir.
Yes, good morning.
Thank you for that lesson.
You're welcome.
Then another thing, you were talking about continuing the topic of vectors. We're doing it tomorrow at same time at 5 or?
At 5. Now, all the vector lessons are going to be happening at exactly 5. We start at exactly 5, so meaning
Yes.
you must come in a bit before 5, early.
So now, it's going to be every day, like from Monday to Friday?
Yes, every day.
Okay.
Because vector is a bit lengthy, so I want, but by the time, in fact, so far, the first 2 parts, they have about 11 lessons. So I'm thinking if we meet every day, by the time the holiday will end, we shall have covered around 90% of vectors. Okay. Lastly, I want to pick maybe Sajabi. Sajabi?
Thank you, sir, for this opportunity. Thank you so much for the lesson.
Okay.
Enjoyed it. Yeah, my question is, they told me about the sample, like UNEB sample papers being released. Is it true that they are out or not yet?
Not yet.
Oh, thank you, sir.
I know you are seeing some papers on different platforms. Those are just things that people are coming up with. But let's be patient. But the most important thing, make sure that you are well conversant with the application of the what you are learning in class. You can apply that knowledge to different scenarios. Yes, that's the Docus.
Yeah, thank you, teacher, for the lesson. So I'm inquiring if we're also going to learn differentiation too.
Yes, we are going to learn differentiation too, where we have mathematics on the timetable.
Okay, teacher.
Yes, scenarios for vectors, yes, we shall have those scenarios, Yeah, but like we are going to be building, by the time we shall finish the topic, we shall have looked at quite a number of scenarios, and then I'll give you a scenario that combines everything. But also you are going to find out that in the process of us covering this topic, we are going to bring in other topics you have covered. A case in point, you may find that in vectors, you are going to need the knowledge of quadratics that you covered already. So you'll find that there are some concepts we are going to be borrowing from those ends and then applying them here in those topics you have covered. Okay. Now, for the number of questions, the paper structure, and the rest of that, I'm going to request you that you be patient until when UNEP releases everything. There is something still in the kitchen that is being cooked. I know for elements of construct, I know there are some things you have been seeing around, but that's not yet the final thing. Those are just things that teachers are coming up with, but the real ones or the exact things that are going to be followed during the setting of the exams will come out. UNEP is going to list them, but I think it may be after this month, those coming months, they are going to release them. But everything is ready. But just we want to ensure that everything that comes out is perfect. Yeah. But keep interacting with the scenarios, keep interacting with that. Make sure that you know the concepts, because it's going to be very easy for you to apply if you know the concept to use. Okay, thank you so much. Let's meet at 2 and then tomorrow at exactly 5. Have a lovely day, everyone. The lesson will be available. Those who came in late, we shall have it on YouTube.